In this video, we'll take a look at possible symptoms you may see on a phone. In this case, I'm going to be illustrating a 3PCC phone that's registered to WebEx calling. This phone I've not had any issues with. I am going to inject elevated levels of mDNS to the LAN where this phone is at. And not only is this phone going to have issues, I'm using a 8851 phone with a chem, specifically with a BE chem. I also have other phones like 8845 phones. They also are exhibiting issues during this testing. DBS 210 DEC phones also exhibiting issues. And also I ran into some issues from this elevated mDNS traffic with some Wireshark capturing, even though the system I was using had more than enough resources and it wasn't a resource issue. It was just kind of ill effects of elevated levels of mDNS traffic. So specifically in the phone itself, what are some possible symptoms you may see? One common symptom is going to be delayed response. It's almost like the phone is lagging a few seconds. Sometimes it may be longer periods of time, 5-10 seconds, possibly longer. Sometimes it can be shorter, just like 1-2-3 seconds. Poor audio quality, and I think once you've video that I've captured during the testing, you will notice definitely quality suffers quite a bit. Calls not completed. You'll see a number of calls that are not completed. Also potentially calls being dropped just because there's such a high lag time on the phone where the phone is located due to the elevated levels of mDNS traffic. What is happening? The mDNS traffic is using up the resources that device has. Typically on larger devices such as PCs, servers, or any device that has a lot of RAM, a lot of CPU resources, even though it still has to address all those mDNS traffic events, but it has enough resources that typically you won't see, it won't be noticeable basically. There's other devices, they may not be real time, and again, you will not notice it. Generally, this would be noticed on devices with smaller CPUs that you would interact with in real time. So basically, IP surveillance cameras, telephony equipment, UCI interfaces or user control interfaces in large meeting rooms where you would interact to open up shades, volume up, volume down, lighting, etc., etc. Those devices with smaller CPUs, such as I just named, you will typically notice negative effects. Web GUI of the phone can't be accessed. PRT, problem report tool, can't be generated and or is missing log data. Wireshark not operating correctly on devices, phones, PCs, etc. So I did run into this issue. I was using actually a very powerful PC, so it wasn't a CPU issue, it wasn't a RAM issue, it wasn't a storage issue, it wasn't an I/O issue as far as IOPS on the SSD drive. There's something really with the mDNS traffic, how it interacts with the application, and or my assumption is there must be some safeguards at the kernel level or the NDUS level that is causing some limiting factors, and why in this case what I noticed was even though Wireshark was running, I could not stop it, I could not start it. It was just kind of in a state where it's there. Everything else in the computer is operational. The computer itself was not showing any slowness, so I can do other stuff without issues, but Wireshark itself really was not usable. The only way to stop Wireshark was via Task Manager. And there could be other potential symptoms I'm not naming here, but these are really kind of the symptoms I had noticed during my testing, kind of what I've listed right up here. Towards the bottom of the screen, this is a snapshot of a mDNS capture I did after the fact. So this is once I stopped generating elevated levels of mDNS traffic. And also as a footnote, in this testing I was quite limited. I don't have access to a a.k.a. Spirent or Xena box, so I was using software and a couple notebooks. The traffic I was typically generating was very low as far as megabits per second. Generally, it was somewhere from 6 megabits. Normally, it was averaging around 26 megabits, and I think I could not exceed 31 megabits. So the traffic levels were actually quite low. But you will see during my testing footage, it did generate quite a lot of problems as far as doing any type of basic phone call transactions. Okay, and then this just kind of goes over some basics. This is from Wikipedia regarding mDNS. And really, mDNS is designed for small network deployments. And I'll kind of go over this area right here. When an mDNS client needs to resolve a host name, it sends an IP multicast query message that asks the host having that name to identify itself. That target machine then multicasts a message that includes its IP address. All machines in that subnet then can use that information to update their mDNS caches. And it's small quantities, actually this works fine. Most of the time you won't notice any issues, if you will. The protocol itself, I can tell you, does not scale well, especially if you had to deploy any type of solution at a larger venue, stadium, convention center, airport, hospital, theme park. It is trouble. mDNS is trouble if you're dealing at large scale, or if there's a device or devices that are misconfigured or have some type of issue and they're spraying into the network, injecting, if you will, elevated levels of mDNS. So that can be a big, big problem. It is used on the different operating systems, Apple, Windows, and Linux. So it is, if you're using basically any compute device today, you are using, or you do have presence of mDNS, but again, in small quantities, typically not a problem, and you won't notice it. Okay, so the multicast IP address for mDNS, the multicast group, if you will, is 224.0.0.251, so that's for IPv4, and then IPv6 is FF02::FB. The interesting part is, at least with PCs, when they're doing a transaction for mDNS, they'll concurrently do IPv4 and IPv6. If you're having issues, I would suggest, as far as the network being saturated with elevated levels of mDNS, is one easy approach is to actually disable the IPv6 under the NIC card properties for that PC, just unchecking it temporarily. Generally, you don't even have to reboot the PC, at least in my testing with Windows 10. Simply unchecking this will stop the PC from spraying the network with IPv6 mDNS traffic. So that could be a reduction if you have like a single PC that's spraying the network with elevated levels that's causing headaches. Just disabling the IPv6 on the NIC card could cut the traffic by 50% potentially. And then a specific UDP port it uses is 5353. That's for both source and destination. And then the rest of this, I would just suggest go ahead and go to Wikipedia. Also, there's actually quite a lot of studies, if you will, that different folks have done. There's also a number of good videos that folks over years have posted on YouTube regarding mDNS and some of the challenges mDNS, specifically wireless and deployments and scale, that it can introduce. So generally, if done in small quantities, it's okay. If you're introducing wireless into the mix, which we're not talking about today, that can be problematic even in small quantities. Or as you increase the volume of mDNS traffic, that also can be problematic. As I mentioned, I did run into issues with the PCAP that I was capturing during my testing, and I was not able to recover it. Again, even though I was running very low volumes of mDNS traffic compared to what a computer that has a lot of resource can normally consume, it was really something in the mDNS traffic that was causing issues. And what I'm going to show you is what is normally seen, or what I have on my network when I'm not synthetically generating elevated levels of mDNS, what it looks like. So this was taken over a little bit less than a 24-hour period. I want to say maybe 22 hours or so. So let me go ahead and bring up a graph here of this really quickly. And what you'll notice is the traffic is very minimal. So I have approximately anywhere from 4 to 6 PCs. Again, this is a very small deployment, kind of my lab that I use. So during the testing, it was only 4 to 6 PCs. If you notice, the majority of the time, the packet rate never exceeds 10 packets per second. It's hovering around 8 on these peaks. These larger peaks that jump up into the mid-50s and mid-60s, this is actually when I was powering on a laser HP color printer, but then it subsides very quickly. So this is kind of, I've never had issues with any of the PCs, printers, any of my MPP phones, a.k.a. 3 PCC phones with WebEx calling, my DEC phones, which are the wireless cordless phones, again, usage with WebEx calling, ATAs, or any of those devices, they work perfectly fine. And this is the normal pattern of what we see almost in a 24-hour period. I want to say this, again, is probably around 22 hours of record time. So very, very lightweight. Most of the time, it's below 10 packets per second on these peaks. And there's a lot of idle time here, if you notice. And then once I bring up a printer, this was actually from a shut-off mode, powering it on. And in most cases, if this is office environment, you're not going to be, printers are typically going to sleep mode, but you won't be powering them off 100%. It is true if you have a very large subnet, your basic floor noise of what's going on can be much, much greater. And this is really where considerations when the network's being deployed really need to be made. How large are you going to have your subnets? How many nodes? Generally speaking, if possible, most folks per VLAN do a /24 for the mask. So basically 254 devices. If it's a situation you need to go beyond that /23, 512. But be aware that as you start inching up into those 300, 400, even if everything's working correctly, your noise floor level as far as ARPs, broadcasts, mDNS, other multicasts will start increasing. And all it takes is really just one device to have some type of issue, driver, update, application, misconfiguration, or something to go wrong, and it can trigger a cascading effect. So you just want to be very careful if you have a lot of devices in one subnet. You do need to be vigilant. And what I like to do is, when you first deploy network, take a baseline. So you deploy the switches, you get the default gateway DHCP configured, and before you have any quantity of devices on it, do some basic Wireshark captures. They can be 30 seconds long, minute long, whatever you feel is a good number. Just have a baseline, and then as you're increasing the amount of devices, PCs, printers, IP surveillance cameras, phones, etc., you want to take snapshots as you're increasing to see, are there any negative trends you're seeing? If you are, you want to go in and focus on addressing those negative trends. Are we seeing excessive ARPs, broadcasts? Are we seeing devices spraying the network with excessive packets regarding mDNS or some multicast traffic? So this is something definitely consider, and this is where the risk benefit. To have one large subnet, the benefit, it's much easier. You just plug stuff in, it's all one large subnet, one VLAN. You really don't have to think about making custom configurations, etc. The negative is, as you scale, the risk becomes greater and greater. For the rest of the video, I'm just going to show you raw footage of the testing that I performed in a lab, other than me actually testing the phone and then talking into the phone to see what the latency and functionality is. I'm not going to really make any other comments. It is a little bit longer video. Feel free to stop at any point of time, but I think it's really critical to hear, see, and feel what the delays and latencies are to understand if this perhaps matches the symptoms you may be seeing yourself. As far as fixing the issue, the simplest approach is figuring what is generating the elevated levels of mDNS. In this case, I was using 3 notebooks to generate elevated levels of mDNS. My solution was simply shutting down the software that's generating it. The problem disappeared right away.
Testing, 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 testing. 1 2 3. 1 2 3. Testing. Testing. 1 2 3. 1 2 3. 1 2 3. 1 2 3. Testing. Testing. 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9 10 10. Testing, 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 testing. 1 2 3. 1 2 3. 1 2 3. Testing, 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 testing. 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9 10 10. Testing, 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 testing.
Is not available to take your call. Please leave a message after the tone.
Testing, 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 testing. 1 1 2 3 4 5 6 7 8 9 10 10. Testing, 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 testing. 1 2 3 4 5 6 7 8 9 10 10. Testing, 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 testing. 1 2 3 4 5 6 7 8 9 10 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing.
Reach is not available to take your call. Please leave a message after the tone. Press the pound.
Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing.
Reach is not available to take your call. Please leave a message after the tone. Press the pound.
Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, 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 testing. Testing, 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 testing. Testing, 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 testing.
We're sorry, your call cannot be completed at this time. Please hang up and try your call again.
Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, testing, testing.
This time. Please hang up and try your call again later. Thank you.
Testing, 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 testing.
We're sorry, your call cannot be completed at this time. Please hang up and try your call again later. Thank you.
Testing, 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 testing.
Your call cannot be completed at this time. Please hang up and try your call again later. Thank you.
Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing.
To reach is not available to take your call. Please leave a message after the tone.
Testing, 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 testing. 1, 2, 3, 4, 5. One, two, three, four, 5, 6, 7, 8, 9, 10. Testing, 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 testing. 1, 2, 3, 4, 5, 6, 7. Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, testing, testing. 1, testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing. 1, 2, 3, 4, 5, 6. Testing, 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 testing. 1, 2, 3. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing.
Trying to reach is not available to take your call. Please leave a message after the tone. Press the pound key to...
Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5. Testing, 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 testing. 1, 2, 3, 4, 5.
Okay, so what can we do to actually fix as far as considerations of the mDNS elevated traffic that is causing all these issues? In this specific example, all of the phone issues that I just illustrated during the testing. Step number 1 is really identifying the source of the elevated levels of mDNS traffic. Is it just 1, 2, 3, 4, 5 devices, a few devices? If so, is that the expected behavior from those devices for them to be generating elevated levels of mDNS traffic? And basically, for the normal traffic for the respective device / application, you would want to check documentation, the website that's related to the device and or software to see if there's any comments regarding mDNS settings, that the drivers, the software, the device itself, let's say it's not a PC, but it's some type of barcode scanning device or barcode printing device or something that's a back office type of device, and seeing if there is anything maybe that's a misconfiguration, older drivers, application. There's a whole list of different things, but you would want to get somebody with expertise on that involved. And that's where this next item comes in. Contact the respective manufacturer of the device to get help regarding fixing the elevated levels of mDNS traffic, and basically just get an idea what is the expected behavior of this device regarding mDNS. If it's expected to have elevated levels of mDNS traffic, which kind of would be unusual because it can be very destructive, as you can see from the testing that I did, you would want to figure out then what is the recommended best practice for deploying that device so it doesn't affect different things you may have in your network. They're sharing the same broadcast domain. And that brings us kind of to the last topic. Considerations if it's possible to isolate and or filter the mDNS traffic from the source device or devices. So you want to definitely be careful before you consider isolating either the sources of the mDNS traffic, elevated mDNS traffic, or isolating. It is common practice to place telephony equipment such as VoIP phones, a.k.a.s, DEC, and other telephony equipment into quote-unquote a VoIP VLAN or voice VLAN. So that may be, do we place the mDNS devices generating elevated traffic into an isolated VLAN, or vice versa, the phones or whatever else might be having problems with that. And you would need to make considerations because there are certain applications, and mDNS is an example of such a protocol that is not routable across layer 3 boundaries. There are special provisions, especially for Wi-Fi deployments, where that mDNS traffic can almost like be tunneled, if you will, propagated, almost like a unicast traffic, but there are a lot of caveats to that. So you definitely want to get somebody with expertise involved. As far as what can we do from a switching standpoint other than VLANs, it really depends on the make and model of switch you have. One assumption is you have a manageable switch if this is a business environment. If you have a manageable switch, then generally VLAN would be one approach. However, that may not be practical because that would be a different subnet, and then a different subnet does need to be NATed out, and there needs to be security changes in a firewall, etc., etc. You can also look at storm control. Enterprise switches typically have storm control commands for broadcast, multicast. You can configure on a per interface basis. They're typically done in percentages. That's one consideration. That may be more of a band-aid. ACLs may be another consideration. You do have to be very careful with ACLs so you fully understand what is the expected communication amongst different devices at different times. And it needs to be documented very carefully so in the future if there's any type of moves, adds, or changes, it doesn't turn into a big disaster. In any case, hopefully you got an understanding of some of the symptoms they may be present if there's elevated levels of mDNS that is bombarding 3PCC phones, also known as MPP phones. The specific example I show is with WebEx calling. And as I mentioned earlier, never had issues with these phones up until the point where I introduced the elevated levels of mDNS through synthetic means. If you're running the same issue, I recommend, if possible, see if you can do some Wireshark captures. It is problematic trying to get captures with this protocol. As I mentioned here, I did run into issues even though I was using a very powerful PC, and it was in a situation where it was not enough CPU, DRAM, or storage. mDNS can be very difficult protocol to work with. So in that case, you may want to put a timer, like a 15-second, 10-second timer, 30-second, whatever you think is within a safe zone when you go do a Wireshark capture to capture some actual evidence. In any case, thank you for watching this video. Hopefully it helps you.